So I start by saying that I hope that it's not very bad what we did. Or very wrong, I mean, it's not bad, but so I'm Claudia Marinica. I'm an assistant professor in the Paris area, and I'm in computer science. So I will talk today about the PARCOUR project, which is a project around the conservation and restoration of artifacts. So I'll give you the details a bit later. So first of all, before starting the talk, I wanted to thank the two persons who worked on this project. They were postdocs. So first of all, it was Sheikh, who worked for some time, and then Ines, who ended her contract in January. So thanks to them, because I was there supervising, but they did a lot of the job. So, okay, you have here some table of contents. We'll go directly to what we will discuss in details. So I will start with the context and motivation of the project, and then to discuss the real work that we did. Okay, first of all, the project. The project name is PARCOUR and is there. So the name is Cultural Heritage and Conservation Restoration, an ontology for the use of a common reference for different data sources. You have a website that is not very complete. I have to do it. So it started some years ago. It was supported by the Foundation of Heritage Sciences. It's a foundation that is located in Cergy-Pontoise, and it's kind of part of the university. So it's something the foundation started 8 years ago. So the government funds the foundation, who funds projects and so on. And you can see that in this project there are several partners. I will just sort the partners on the contribution that they make. Here is the name of my lab, the ETIS lab. We are a computer science lab, so we are there to bring the computer science information. There is another lab, research computer science one, the David, which is in Versailles, next to the castle. But okay, they participated, but on another side. And you can see also that there are several institutions that are conservation restoration institutions. The C2RMF, sorry, you know, I'm living in France. In France, we have all the time abbreviations. So don't ask me why I'm Romanian, but it's like this. So C2RMF, they are mainly doing analysis and working on the conservation restoration part on paintings, objects, etc. LRMH, they are working mainly on buildings, but also on objects. So we can have from time to time objects that are analyzed both by C2RMF and LRMH. We have on the first part, on the first line, sorry, the CRCC. CRCC, it's a conservation institution. They are there for the document, so the manuscript, etc. And then you have other labs like Ipanema, INP. They are a bit less involved, let's say, in the project. Okay, what was the goal of the project? That was very easy at the beginning. We said, okay, you in C2RMF, you have data on the objects that you are analyzing, on the artifacts. LRMH the same. Let's try actually to do an information system that will allow the conservators to have access to all the data that were the results from the analysis from the two sides. Of course, without modifying any database, because you know very well that the cultural institutions do not want that, to modify a lot or to move the databases somewhere else. So that was the goal of the project. Okay, so I already said a bit on the motivation of this project. You know that during the conservation and the restoration of artifacts, the conservators or the other people, they are producing a lot of data, and it is difficult to put them all together because they are really not talking the same language, let's say, in the different databases, and what are the important issues that we should solve. And actually there are interoperability issues, is that the data are distributed, so they are maybe isolated, etc. We have to have a way to put them together. The data, that they are heterogeneous. I mean, as I was saying earlier, maybe a term does not want to say the same thing in the different databases. There is also maybe a lack of semantics, and I will give you an example later. For example, we have bibliographic databases where we have only a field keyword, and there you have all the analysis, the technique analysis. Okay, what do we do? What do you do with that? We have also terminology ambiguity, etc. And of course, yeah, earlier I should have talked about databases that are different. There are relational, NoSQL, and in different formats and so on. So that was our case. The database of C2LMF was a relational database with different tables, and for LRMH it was a bibliographic one. Okay, so the goal I already discussed a bit about that. The specific goals and what we did during this project. The first one, what we wanted is to produce common shared reference, okay, on the conservation and restoration data, in order for the people to have a common understanding of the area, but also a common evaluation, and in order to be able to use that to access the different databases. Okay, so what we did on that, we produced a common conceptualization under the form of a conceptual model. The second point, once we had this conceptual model, what we wanted is to be able to produce a system, an information system, who would allow us to access the different databases that were still at the institutions, as the conservation restoration institutions, and then to get back information, for example, about the La Joconde. If they did both institutions different analyses on that, we should have had all the information together. Okay, but to do that, we had a lot of questions. Don't worry, I will not really detail all the questions because we will be here at 4 also, but I will just show you the questions because I think it's important, the questions that we ask ourselves when we want to do this kind of projects. The first one is that, is the database semantically ready to integrate a unified query system? The second one, are there any terminological heterogeneity and ambiguity problems in the data? What constraints and steps to produce a shared conceptual model? The fourth one, how to query the databases by using the shared conceptual model, and how to query the distributed databases, and which kind of architecture we should use. So you can see we will focus today on the third point because this is what interests us. Nevertheless, I will still pass on the fourth other points, but very quickly, just to show you the problem and the result without going into details. Okay, so we go to the part of semantics in the databases. So are the databases semantically ready to join this kind of systems? The answer for us was no, for the bibliographical database. So you can see here on the right, this is an entry in the database. So the main problem was this field, mots-clés, so keyword. You can see that here you have a lot of keywords, including analysis technique like spectrometry, the type of the artifact, tableau, technique, peinture, so on, cathedral, because I think that there is a painting who was in a cathedral that was analyzed here. So our main idea here was to be able to take these keywords and to classify them in different classes. So for that, we took a lot of available vocabularies, let's say, and we tried to match these keywords and to class them. So we built a tool that allowed us to do that. And so we had 10,000 keywords that we had to class, and we managed to class 7,000, and we created 12 categories with our classes. So you can see that, okay, the rest of them, I think that they should be done quite manually, because even with all the vocabularies and lists and etc. that we couldn't do it completely. And what about the heterogeneity and the ambiguity? Indeed, this is the case, and this exists in all the databases. The idea is that we are not always sure that all the practitioners, when they are using a term, they are using for the same meaning, etc. For example, they have abbreviations. You can find in one database the methodology that is abbreviated, and in the other database you have the same methodology or technique that is used with a complete name. So what do? You have to know that these are the same, right? You have generic terms or specific terms, but at some point you have to class them in order to be able to know that if you are talking about the generic term, maybe you should take into account the specific one also. So in order to manage this issue, we developed, and we are still developing, a set of thesauri. Okay, as you can know, or vocabularies. This is a quite challenging task, and it takes a lot of time. So to do that, we are using a tool that was developed by the Ministry of Culture in France. It's the Jinko tool. I don't know if you know it. In the Jinko tool, you have a lot of vocabularies that are available. I mean, all the institutions that are encouraged in France to use Jinko. So I think that this is a nice resource of vocabularies. At some point, if we need a vocabulary, we can at least go and see if there are any which are available and validated by the teams, because this is very nice. You can also put your vocabulary in standby if you are not sure that it's validated and so on. So this is interesting. So we wanted to produce a set of thesauri of alteration, of manufacturing techniques, of analysis and examination techniques, intervention techniques, and materials. For the moment, the team that was working on this managed to develop the third one. And it's something like this. You have, it's a thesauri, it's a thesaurus, sorry. So you have as top level concepts chromatography, scientific imagery, chemical measurement, physical measurement, spectrometry. And then if you are really interested, I can send you the file to have a look, or to use it if you need it. So now that we discussed about the databases which were ready or not to join a query system, we can go at the development of the shared conceptual model. And actually, I will discuss first very quickly about the requirements or the needs of the conservator, I mean, of the field of conservation and restoration. Okay, I will go briefly to the definition, because we had it last time in June, and this time you discussed a bit. So the ontology that we would like to build for the conceptual model is a more abstract model for the conservation field. And to do that, we have to semantically classify the concepts that exist in the domain. And the idea is to make this classification understandable by the computer in order to be able to use it. So we'll use web semantics languages. This is quite important because here we are addressing the needs that the conservators had. So what they were needing exactly? For example, they were. We asked them to ask themselves some questions. I mean, what they needed really to have in this ontology. For example, they needed to understand what kind of static what kind of static information could describe the artwork and its identity. For example, here we talk about identifiers, authors, typology, form, dimensions, manufacturing material, location, etc. What kind of alteration can affect an artwork? What do you need to keep as an information about it? For example, you have degradation, aging, attacks, so on. And this links a bit with the talk that we have earlier, and I was thinking of that I didn't use the same thing, so we'll see. What kind of scientific studies can be made on the artifact, and what will be the result and how we can model that. So here we talk about diagnosis, studies, sample taking, imagery, so on. And what kind of intervention can be undertaken on an artwork, and the same why, what is the activity which implied this intervention. Okay, as I said earlier, the conceptual model that we proposed is based on CDOC CRM. But not only on CDOC CRM, we also used CRM science. So in the following part, you will see in my presentation in blue the CDOC CRM, in green CRM science, and in orange the classes and the properties that we added in the extension, I mean, what we are calling extension. Not validated, that we are calling CRM-CR. So this is what we propose, and the classes begin with C and the properties with R. Okay, so here actually I will step on because I'm just looking at the time. So let's see how the ontology that we propose should meet the requirements of the conservators. So here actually we have, I go a bit down, a physical man-made thing. So this is the class of CDOC CRM, and normally the artwork should be somewhere here under the physical man-made thing. Earlier we were discussing yesterday, maybe it should be under objects, so this is still a question. So here we have the identification part. On the right we have the event part, the event identification with everything that we discussed yesterday, also the place, the actors, the time span, and so on. And what interests us is the activity class, because from here we are heritating, we are producing all the other classes that interest us. So for example, we have all the scientific studies and results that can be undertaken on an artwork, and for example we can have observation, measurement, sample taking, so on. You can see that a big part of elements were taken from CDOC CRM or CRM science, but we can see that some of the classes that are interesting for the conservation and restoration does not exist in CDOC CRM, which is normal because it's quite generic. The scientific analysis, the imagery, so on, we will see that a bit later. And here we have the alteration concept, which allows us to describe all the alterations that, the modifications that arrive on an object, but that are not wanted, the damages. So we have these alterations will indicate that there is an intervention that should be produced. So the interventions are the tasks of the conservation restoration, and we have all the documentation part here. The last part is the part of the measuring instruments. So there also we define some of the elements, the technique and the instruments. I'll show this later how. Okay, so here I just presented how are organized a bit the needs that we were having, and here how exactly we connected this to CDOC CRM. So here we defined a class that we called cultural object under the physical man-made thing, which is here, because actually we needed to define what we are calling a movable cultural object and unmovable one. So I think that here we should discuss a bit this afternoon, because maybe this should go on the CRMBA extension, which is the one for buildings. Because as I told you earlier, some of the institutions, they are also working on buildings. Okay. We have on the left all the part on the localization and owners that I will detail about later. The measuring instruments, so here, or maybe I will talk about the events first. So you see that the event, as the usual in CDOC CRM, is central. So the object was affected by an event. This event can be an activity, which actually can be a scientific study, an intervention, or an activity of documentation. And on the other side, we can have as an event that affects a cultural object. We have the alteration, and here we have a description of the alteration. What is important to see is that an activity is following a procedure, and this is quite important for the conservators to be defined like this. I mean, we try to make things a bit simpler and to use only the CDOC CRM concepts, but the conservator told us, no. There is an activity, but we have a procedure. The procedure is using a techniques which is supported by an instrument, and the procedure is using an instrument, and the procedure can use another material. For example, when you are doing a test, you can use a product in order to get a result. Okay. Well, you see that. So, for example, for the identification, so we have the cultural object, which is here. We have all the appellation part, which is here. Of course, we are using the classic elements that exist in CDOC CRM, the identifier, title, so on. There was a need in our project to have an inventory number, and actually in all the subclasses of the appellation, for us, but still we have to discuss that. There was no subclass that for us we could have used as an inventory number. So this is why we added. Then we have a class in order to indicate that the cultural object consists of a material that has a shape and a domain. For example, there is a painting or something else. And we have all the parts of condition state that we find in the top right here. I'm having a look, maybe I try to go a bit faster.
You're right, don't worry.
So, Further on, I'm showing here the way that, for example, we attach the author to the cultural object, and as you well know, we cannot do it directly. We have actually an event, an activity of production, which is attached to the cultural object, and then the author, which is attached to the activity of production, because the author carried out this activity. What we needed to add here, it was actually a technique that was used, a manufacturing technique that was used during the production activities. Okay, the events that are undertaken on an object, we sorted them, we classed them in two types: the degrading one, and the non-degrading, because that was important for the conservators. Degrading one are the alterations. So here you can see the alteration in the center, because it's actually an event which will modify the state of the cultural object. Okay, so the cultural object was alterated by the alteration concept, so these are coming from theorem science, and what was important for us and what we didn't find in theorem science is to define the area where the alteration took place. So we have an area, but what is important in the cultural object is, for example, to know if the area is a surface or the area is a support of the support where the object is posed. Okay, it's positioned, to know that. And also what kind of alteration. For example, we can have the formal restoration or just aging and so on. Okay. This is for alterations, and the non-degrading events are the activities. So the same, we have the cultural object that was affected by an activity, and here we have different types of activities that are allowed by theorem science and that are very interesting in conservation restoration. For example, the sample taking, and we have different descriptions of the sample taking that are coming from theorem science, and we didn't touch on this part. But at the same time, we have all the measurement and observation. Okay, the difference that we did between the measurement and observation is that observation is less scientific, let's say, than measurement. This is what we understood, and we can still discuss, of course. So this is why, so this is what we understood from that, and we added here the studies or the measurements, the observations that were interesting in the conservation restoration: the scientific imagery, spectrometry, chromatography, photography, radiography, microscopy. Okay, so for example, maybe I'll pass this slide because it's just giving examples the same but with some instantiations. And what is also important for the conservators is to have a place where to put the results of the analysis. So a measurement produced, what we define is that a measurement produced an information object, but yesterday during what we did with Robert, I think I was thinking that maybe we could have used a property that exists already, but we didn't find it. But okay, we can still search. So an information object, which is actually a document. So we are talking about a document when you have, or a visual item when you have images. a document when you have a spreadsheet with the information, so on. So here for the visual item, you can have a spectrum, a curve, really an image, and so on. And we needed really to have for all these elements a URL defined website, so on. And also the results can be something that is a dimension with a measurement unit and the number. Okay, so here you have the same thing, but with the instantiation, which would take me 5 minutes to explain. So you have a cultural object that was affected by a type of microscopy, so you have the instance of that, and which measured a material that was undertaken from the object, and it was also affected, for example, by a photography, and you have the area where the photography took place, and you have also some elements about, you see here, there was another measurement by on another part of the element, and you have some results as a dimension, and you have the results of the dimension. The last element on the non-degrading or degrading events are the intervention events that we added in the ontology, because what we consider is that an object was affected by an alteration. When the alteration was produced and when somebody saw that this alteration was produced, an intervention should be done on the object to restore or to do the conservation and restoration task. This is where it comes. And actually, to do that, we use the hierarchy defined by the International Council of Museums, the Committee for Conservation. So we have the intervention, and for the intervention, we can have different types of intervention, the conservation or the restoration, and we have different types of conservation, preventive conservation, remedial conservation, and so on, and this is the same for the restoration. This way, to be sure and to understand which type of intervention the conservator or the restorator have to do on the object. Okay. Here we discuss about the analysis techniques that have to be used during the scientific studies mainly. So what we did, as I told you, is that we were considering that an activity follows a procedure, that the procedure uses a techniques, and this procedure uses also an instrument. Okay? And these techniques, you have different types of techniques that are intervention techniques and analysis techniques. And you can have here the scientific imaginary techniques and the spectrometric techniques and so on. Okay, so I finished with the presentation of the ontology. I will just go to show you what we did with it. So the fourth question that I was having in my presentation is about how querying heterogeneous data sets by using this ontology that we produced. So we consider that here we have the two databases, the one from C2RMF, the second one from LRMH. This is the relational, this is the bibliographic. We have the ontology here. The idea is that the two databases, they are staying in the institutions. They are not moving. Okay? What we did is, with a set of tools, we use the ontology in order to produce data knowledge, a base of data knowledge, two bases of data knowledge, sorry, and actually these knowledge bases, they are staying in the institution. And what we did is that at least, I think at 2, but at least at C2RMF, I know that every month they are regenerating the database in a triple store. Okay? Wait, sorry. I thought I had another slide. So to do that, we use the ontology and we built sometimes using the tools, but mostly manually, mappings between the ontology and the database. Okay? The ontology is indeed talking the same language for everybody, but it's not enough. You have to say who is who in the database. So you have to say that this field in the database relates to this concept in the ontology. This way, the system that we'll have on top will be able to use the ontology in order to get into the databases. Okay? When we did that, when we produced the mappings, with the mappings we were able to produce these knowledge bases, which are actually triples, RDF triples, okay? That are on the base of the ontology, but it's just, I mean, the databases, through the ontology, they are produced in the form of RDF triples. So this is for the knowledge-based development. Then the last question, how to query distributed databases and what architecture for the system? Well, this is it. So there are many questions and many problems, and we didn't solve them all, don't worry. The first question that we didn't solve, because we said that is not that important, is how to translate the user queries, the user, I don't know, natural language or whatever, in PARCOUR language or whatever language. And this is a real important task, but also difficult, so we need another postdoc to work on it and to do something nice. Then another question was how to send the queries to the knowledge bases, and actually we need to have what we are calling in the integration data field, computer science field, we have to have what we call a mediator to be able to mediate the queries. So there is a query that comes, and the mediator has to say, okay, I have to do the databases, I have to send them queries. What do I send to them and why? Okay? And then we have to manage to get back the answers to show them to the users. So for example, I imagine that I send the queries to 2 databases or to 3 databases. I get back 2 or 3 answers for the same object. So I have to find a way to put them together and to show them to the user in a nice way. Or if I get only 2 answers from 3, should I ask myself why? Or, okay, I should be able to manage all these questions. To do that, I have the 2 knowledge bases that we discussed earlier. I have the ontology. I have the theory that I developed, because this is also important, the theory that are connected to the ontology, okay, in the leaf. And here I have a set of reasoners from the web semantic that allows me to put all this together, and when a question is coming from the user, who is here, very smooth, when he's asking a question, the question is getting down, and the mediator is able to send the question to the to here actually, and the reasoner is taking both data acknowledges, the ontology and the theory, and putting all this together, and is inferring, what we are calling inferring, and getting a result. So we produced what we call the proof of concept. So it's not definitive. It's so here you can see that we can search. We produced some some coded queries that we were searching cultural objects that was affected by alteration like deformation and crackles, and that were affected by analysis, by some type of analysis, we don't precise, and we want the dates and the authors, so we get a set of results. This is what we did, but what is important is what we didn't do. So you have here the conclusion of what we did. The first thing is to validate the ontology, and unfortunately, I don't know, I had to come some time ago to Lyon to present this, and I was sick, so that's life, and then we couldn't, so I hope that we can do it in March, I think. We have also to process the queries that are coming in natural language processing, because this was not done. We are sure that we have some work on query optimization, because this takes some time when you are sending a query, and this is not what conservators want, but this is quite logic, because all the web semantic stuff, when you put it together, okay, it takes some time. And now what we are working on, when we are quite happy, is that we want to build a tool like an online knowledge data production for the conservators. The idea is that the conservators that do not have a database to put the information inside, to provide them a tool, an online tool, to put the results of their analysis in this knowledge base. And I say knowledge base because we want it to be directly set of triples, RDF triples. So for example, we will produce a tool that will have the structure of the ontology that we already produced, and in the back, once the conservator is clicking send, the data is stored as RDF triples, and we can inject it, we can use it directly in the system that we produced. So for this, we are happy because we just got a funding, so we are expecting for the money to come and to start the work. We get the funding from the National Research Agency in France. So thank you, and questions and remarks with what we didn't do well. Thanks.
Right. You have sources, databases in different institutions.
Yes.
So how you solve a problem that they may have different performance, and one of them are slower, other faster, and you're gonna get result only from one first?
We didn't have any problems now not to get results from one, but I think that your question goes in the query optimization part that I said that we didn't discuss it in depth. I would say. We tried to find the most interesting reasoner, for example, not to be very slow, or the techniques in order to reason that fits our case, but we didn't ask ourselves this question. That's interesting.
Each question would normally go to each system.
Yes.
So you would extract all of the data from each individual database,
Indeed.
create your aggregation, and you query the aggregation.
I understand, but usually the question is that if you create multiple databases, so if some of them answering first and other later, so you could wait for all of them answer, it's going to be slower.
Your live questions would only question the aggregation, not the individual systems, unless you've got it dynamically doing it.
But yeah, your slide showed as if it's directly to the knowledge base, not the aggregated system.
Yes.
It's directly to the individual database.
Yeah.
Aggregation.
Yeah.
Do you have the PARCOUR ontology available to share? I know it's still in development.
Yeah,
You
yes,
need
of
to-
course, yes, yes. And if you want, we can put it on the website, the ontology. Yeah.
I'm not sure how to ask this question. In the project that I presented, CrossCult, we had a long discussion with the software developers about classes.
Mm-hmm.
So they wanted to add many more classes to facilitate the programming,
Mm-hmm.
whereas actually the standard model is to use types. So I was wondering what your motivation was to create classes rather than use types.
For example, for all the, it depends where. I mean,
The easiest one with the types of examination. So you had lots of different types of examination as classes. So
the
why-
intervention.
Well,
You-
no, not the
yeah.
intervention, things like spectroscopy or mass spectroscopy, or you had a whole list of them
Okay.
as classes. So I was wondering why you modeled them as classes rather than types. Because in our project, the computer scientists making the software wanted classes
Mm-hmm.
because that's how their previous software worked. So we had that, the difficulty in the modeling was looking at, you have the theoretical idea of how you do the modeling, and then you have the practical reasoning
Mm-hmm.
because it's got to work.
Mm-hmm.
So that's what I was wondering, is what the choice was.
I think the choice was because we found it reasonable and maybe, as I was saying earlier, it was a bad choice. I mean, so maybe we should look into that.
Well, I mean, if you've got the software and it works and programs well, it will do the job.
No, it's not. It's not only that idea. I mean, for us, the idea was to produce an extension that can be used afterwards.
Yeah, I think that, there's a lot that needs to be discussed with this, but I wanted to ask you a similar question to what I asked Rob yesterday. Your interaction with conservators, how did that work? I mean, how much freedom did they have, or how much were you informed by? I mean, did you find that interaction useful, or how?
Yeah, of course. We had really, in the project, a lot of meetings to discuss the elements to put inside, etc. Okay, I find it very well. On the other side, I think that we were not discussing all the time with the conservators that were doing the job. But the people that in the institution was in charge of
Documentation or whatever.
Yes. But I mean, that was very nice. I think indeed, if you have in the project conservators that are doing the task every day, maybe you can have more insights. But that was very nice.
Azadeh?
I had a similar question as Joe,
Mhm.
and now I was thinking about it as more comment or something to discuss is, because first you set an essence that one of the results of this workshop might be to come up with an extension for conservation. So whether for us to think about, do we need new classes, or where do we need new classes, or whether we want to use existing CRM classes and use type, like for degradation or alteration, as you call it, whether we want them to be a type of events or type of observation, or do we want new classes, or for interventions, whether they need to go under, and the way we do is we use activity plan, but if it's dissolved, design and procedure, whatever class we want to use, and then have it as a different, all the preventive measures, interventions as different types that you can add, or do we want to come up with?
So I think the SIG has got certain rules that we try to follow when we decide on a new class or not. I don't know, George,
Well,
do you want to?
she pointed to one of them. I mean,
Yeah.
in the presentation, that you would, you're definitely motivated towards creating a new class if you need
make classes that don't need a property, you can throw them in a type, but there's nothing technically wrong or incorrect about modeling that way, but it just doesn't make the tightest model for sharing with the community. So there are very, good practical reasons for making subclasses of a class that don't have relations, but mostly for writing software more easily rather than making a compact representation of the domain that you want to describe. So if you can gather together a bunch of different procedures that are kinds of the same activity that only have one property, then you make the model more compact and make the ability to learn that thing and share that thing a lot easier. But could I intervene or just following up on that conversation? But I mean, I guess just because I will unfortunately miss the afternoon part, but I do think it's an interesting conversation that begins to develop around how to build the post-workshop conversation, the right virtual environment or what have you, to try, if indeed it's possible, to sort of move forward with thinking about what would be the necessary new properties and classes to represent conservation information. Somehow it should obviously be like a community activity, and so finding the right convenient tools and communication channels for doing that offline between this and whatever happens next is.
Yeah, no, I think very much we're hoping that this network will start that discussion. The more we talk about a conservation extension, it appears that maybe at least half of the types of classes we need for conservation are already in core or other extensions. I'm thinking more about the CRM extension for conservation as a collection of classes from the other extensions, as opposed to more like profile, I guess. Yeah, but there are things that are still missing.
So that's the same conversation we had around making an extension for historical data. It didn't need its own extension, but it didn't mean it doesn't need new classes. But
that's true, they can fit elsewhere. Yeah, I mean, the only problem with that is that, it's nice as a community to think that, we've got our own extension and this is ours, and sort of but actually,
Well, the thing that we definitely do need is the agreed collaborative shared vocabularies.
Yes,
and whether those vocabularies become classes because of the software being built is fine, but that shared vocabulary, there are lots of them in existence, and each system has their own vocabulary, but if we had a conservation set of terms, multilingually if possible, that would be really nice.
So yesterday you missed the session, but there were a couple of slides that we discussed that, and we should go through them together as well.